Hello and welcome back to Handheld Coding OPL. So just so you know, after this episode we'll be taking a short break, mainly so that I can get back on with doing some reviews and fixes and building the channel. But don't worry, if you're enjoying this series, it is definitely going to be completed. Indeed, I'm currently considering extending the course beyond the original 6 episodes. So today we're going to have a look at the use of loops. But first, let me introduce you to the OPL function RND, which is short for random. RND generates a random number between 0.00000000001 and 0.99999999999. So it's very useful for creating random outcomes. For this example, we're going to create a magic 8 ball. I'm going to call the program M8 ball. Feel free to pause the video here and have a go yourself. Otherwise, here's what I've done. So first of all, I've created an array of strings called answers. There are 5 of them in my array, up to 16 characters. The 16 character limit is determined by the Psion 2 screen. I've then created an integer n, which is the output number, and finally a string $, which is 1 character and is for the menu, as we've done before. We've got our start, I've printed focus on your question, and then there's a pause because I've put a get in there. After that, we generate our integer n. So this is equal to 1 plus RND multiplied by 5. So as I said at the beginning, RND generates numbers between this and this, as you can see here. These are far too small for our purpose, so we're going to multiply them up by 5. We now have answers between this and this, as you can see here. But we want the number to go from 1 to 5, not from 0 point something to 4 point something. So we're going to add 1, and now our number goes from here to here as demonstrated here. From here, we're very close to what we need, so we're going to convert it to an integer by making it equal to an integer, and this removes everything after the decimal place. So now we have a range between 1 and 5. If you wanted a bigger range, say 1 to 20 or 1 to 40, you'd simply change the multiplication factor. We don't need to put brackets around RND multiplied by 5, as multiplication and division is always done first before addition and subtraction. Next up, we need to assign some outcomes to our answers array. Once that's done, the screen is cleared. After that, we print our answers string, and we simply do that by substituting the number in the brackets for n%. Then there's a get, so the program pauses until we press a key, and we've got our menu to return us to the beginning. So this works really well, and I'll leave you to put the remaining 15 answers into your magic 8 ball. Just be aware of the 16 character limit. I've also put a link to the wiki page below. So now we can create random numbers. The next logical step is to create a dice roller, obviously. Let's start with a simple one, a d6. Feel free to pause the video here and have a go. We already have covered everything you need to achieve this. So here's how I've done it, and I think it's pretty straightforward. I've created the integer r for result, and then the m string for menu as usual. We've got our start label to bring us back to the beginning, and then I've printed let's roll. I've put a get after that, so it waits until you press a button before generating the random number. It then prints you rolled with a space, a semicolon, and then our resultant r%. Once again, I've put a get there, and then it clears the screen and we go back to the menu. So I think you'll agree this is a perfectly good dice roller, but I'd ask the question, what if I wanted to roll more than one d6, but didn't want to go around the program constantly? So you've guessed it, we're going to use a loop. We've already come across loops using the if, else, if, and if command. So we used it in lock to return us to the start, and we use it in our menu every time in order to return us to the start or to leave the program once the loop is finished. There are 2 other options for loops in OPL. The first is the while end while loop, which tests a condition at the beginning of the loop and then runs to the end. So at the beginning it might be while n is greater than 0, then something is done, then n is reduced by 1, then we reach the end while. And for as long as n is greater than 0, it will continue the loop. Once it fails that condition at the beginning, it jumps to the end while and then continues the program. The second option is the do until. So this works the other way around. It does something, then tests a condition. And if that condition is met, it'll return to the beginning of the loop, do what it's supposed to do, and then test that condition. Once the condition fails, it'll then continue through the rest of the program. Most of the time we can actually use either method. So for the moment, we're going to concentrate on the while end while loop. Before you go ahead and start using loops, it is important to make sure that all your loops have an end. If they don't have an end, then what happens is your Psion will continue in its never-ending loop until the battery dies. You can attempt to break a loop by pressing the on/clear button and Q at the same time, but this does not always work, so you may end up having to remove the battery to prevent the program running and thereby risk losing everything stored in RAM. So just make sure that you are careful when creating a loop that it always has an end. Feel free to pause the video here and have a go at adding in the code needed to make this roll more than one dice. So here's how I've done it. I've introduced a new integer, nr, for number of rolls. The program then asks you how many dice you want to roll, and this defines nr. The program continues the same as before until it reaches our while loop. So as long as that condition is met, it will follow the code below. So let's say nr% is 2. What happens now is it's going to create a random number, print the random number, it then reduces nr by 1, reaches the end while and jumps back to the beginning of the loop. Checks our condition, nr is now 1, so it is still greater than 0. So it will then generate a random number, print the result, reduce nr by 1, hit the end while and go back to the beginning of the loop. This time nr is 0, and because nr is 0, it is not greater than 0. So now the program will jump to the end while and then follow the procedure from there. So we've got a get command, a clear screen, and then we're into the menu. So unlike using an if-else-if loop, we don't need to put a goto and a label in there. So it makes the program more efficient. Just so you're aware, you can nestle with, end with, and do until loops within each other. Up to 8 can be nestled. So now we've got a D6 roller that can roll as many times as we want. But we don't really want a D6 roller, a D8 roller, a D12 roller, you get the idea. So why don't we alter our program and allow it to roll not just the number of dice we want to roll, but the number of sides we want to roll. Pause the video here, have a go. This is quite an easy step. So all I've done here is added a new integer, sides. Then this is defined as an input, and we replace the 6 in our D6 roller with our new integer, sides. I also changed it in the previous program, so it now prints along the same line. As you can see, once we get into double and triple figures, sometimes those numbers are actually split across the display, so we end up with half of it on the top line and half of it on the bottom line. While this might not be an issue in general, it does make the display look a little bit messy. In our first video, we used the @ command to define the column and the line that we were printing on. We could use this to tidy up the display. I would suggest we also make a limit of 100 for the number of sides on the dice, and this means that 99 of 100 will be 2 characters or less. Doing that, we can create an output more like this. Just keep in mind when you have a go at this, the Psion 2 doesn't have a line 3, and if you generate a line 3, it'll throw you an error. We also want to make sure that the lines move up and don't overwrite each other. So pause the video here and have a go. Otherwise, here's how I've done it. So first of all, I've limited the number of sides to 100 by putting a simple if straight after we put in the number of sides. If we're greater than 100, it simply sends you back to the start. So now I know that 99 of 100 rolls will be 2 characters or less. If I assign 3 characters per space, that should give us a gap between each number with the odd exception. So I've defined a couple of new integers, col for column and line for line. Then assign both of these the value 1. So each time we print, we want the column to increase by 3, and that'll give us 2 digits plus a space. And this means the cursor moves 1, 4, 7, 10, 13 and then 16. Now 16 is the end of the line. So the way I've created my if rules is I've said if the column is 16 and the line is already on 2, then I want you to print that 16th character as a space. There's no semicolon after it, and that means that the next set of characters will shunt the line up. We then reset the column to 1. We then reset the column to 1. And the line is left as it is. The other option is we arrive at this point and the column is at 16, but the line is at 1, so it doesn't meet the requirements of the first if. We don't need to print a space, instead we want the cursor to shuttle back to number 1, but on line 2. So we set column to 1 and we set line to line equals line plus 1. Now I could have written line equals 2 and that would work just as well. I've left it this way because on the LZ, for example, you might want line to increase up to 4. In which case, in the first if, you need to alter line to equal 4. You will also want to adjust the column as you have 20 characters on your line. Once that's done, we continue our loop. There are lots of ways to use the if-else-if to achieve the same thing. I think this is the most efficient way, but if you know a more efficient way, I'd love to hear, so pop a comment below. Okay, so now we know how loops work. We've used an if-else-if essentially to create another loop within the program and move the cursor around. But there is the question, is the random function truly random? Now there's quite a bit of debate about this because how can a computer chip achieve a random number? But for this, I'm going to hypothesize that should we roll, let's say a d10 100 times, then if the average of those rolls was exactly half the face value, in this case 5, then if not random, it is certainly a very good approximation to random. So I think we'll use our dice roller program, extend it a little, and test that hypothesis. You're going to need a running total, and you're going to need to work out the average at the end. Feel free to pause the video here. So here's how I've done it. I've added 2 new variables. nr%1 for the number rolled 1 or initial. I've also created a new variable total, which will keep a running total of the numbers rolled. I've then set total to 0. Altered the initial number of rolls input to equal nr1, and that's because if I leave it as nr, it will have reduced to 0 by the end of the program, and then we'll be trying to divide a number by 0, which will just create an error. So now I've said nr equals nr1. Then the rest of the program runs as usual until we get partway through our loop. Now if we head down to our loop, straight after our random number is generated, I've put total percent equals total percent plus r%. So this keeps a running tab of the total number on the dice. Fast forward to the bottom of the program. After our get, I've put a clear screen, printed total, and then followed it by total percent so we can see what the total value was. It then prints average and prints out our average, which is total percent divided by nr1%. As you can see, when we do this, as long as the number of times we've rolled the dice is above about 20, we tend to end up with an average that is somewhere around the midpoint of the face value. So I would suggest that this is at least a very good approximation of random, if not truly random. So as you can see, we've built this program up very gradually and it's become more and more complex. So if you were to come back to this program in 6 months and wanted to try and figure out how it worked, you might struggle. There's 2 ways we can improve this situation. The first is we can add remarks to our program using REM. So REM allows you to put a remark, you can type anything you like following it, and the translation program simply ignores it. So for example, we might put REM nr1 equals initial number of rolls, nr is number of rolls remaining, r equals roll, etc, etc, so we know what all the variables are. In addition, we might put a note at the beginning of the loop to explain that this counts down nr, giving us our total number of rolls. Because the Psion ignores it during translation, it means that although the code is much bigger, the program itself is exactly the same size. The second option is to break down the procedure into smaller procedures or subroutines, and then these are called upon by the main program. And this is going to be the subject of our next episode. So if you've enjoyed this episode, don't forget to hit like, sub, and then ring the notification bell so you don't miss episode 4. If you have enjoyed this episode, if it's been too complicated or too simple, please pop a comment below. I'm still tweaking the final 3 episodes, so any feedback is welcome. As I mentioned at the beginning, there will be a break before I release episode 4. If you're watching this in the future, I'll put a link just here. As always, my name's Hugh. This has been Handheld Coding OPL. Thanks for watching.